All right, for this lesson, we are going to solve some trig equations, but we're going to use some of the identities that we learned. So that helpful hexagon is going to enable us to do that. So let's take a look at that. I put the sine, cosine, cotan, cosecant all in the right order. The Pythagorean identities are formed by your sevens. So there's sine squared plus cosine squared equals 1. So we have that one. And then there's tan squared plus 1 equals secant squared. There's the second one. And then 1 plus cotan squared equals cosecant squared. Okay. Also, the reciprocal functions, if you look at the helpful hexagon, they are directly opposite one another. So sine theta and cosecant theta. So if you see cosecant theta, that's 1 over sine. If you see secant, that's 1 over cosine. And if you see cotan, that's 1 over tan. And then the quotient identities, I like to say cotan equals cosine divided by sine, and tan equals sine divided by cosine. Okay, so now we're ready to do some solving. So all of these find the exact value of theta from 0 to 360. Exact, meaning we should not have to do any rounding. However, if you see two different functions within your equation, you need to remember cosine squared theta is equal to 1 minus sine squared theta. And sine squared theta is equal to 1 minus cosine squared theta from the identities above. So we're going to use those identities and solve these. So for example, number 1 here. We have a cosine squared in the equation and we have a sine theta. That's a problem. We cannot solve 4x squared plus 4y minus 5 equals 0. That's really what it's saying right now. We can't solve that. Okay, that's a problem. However, if we replace the cosine squared with 1 minus sine squared, we no longer have that problem. So it now is an equation we can solve. Now we're going to have to do some distributing. 4 times 1 and 4 times sine squared. So we'd get 4 minus 4 sine squared plus 4 sine minus 5 equals 0. And then if we combine some like terms, we'd have negative 4 sine squared theta plus 4 sine theta minus 1 equals 0. I do not want to ever factor when the leading coefficient is negative. So I'm going to multiply or divide both sides by negative 1. And when we do that, again, we have to distribute the negative 1. That gives us positive 4 sine squared theta plus 4 sine theta. Nope. Distribute. That needs to be minus. And plus 1. And 0 times negative 1 is just 0. So really what we are factoring is 4x squared minus 4x plus 1 equals 0. So let's try 2x minus 1 and 2x minus 1. We need the outers and the inners, negative 2x and negative 2x to add to negative 4x, and the last terms have to multiply to positive 1. Negative 1 times negative 1 is positive 1. So here we get 2x minus 1 basically is equal to 0 because we have two of them. And then that would leave us with 2x equals 1 and x equals 1/2. So putting it back here, I get sine theta is equal to 1/2. So I have to set up QRS. Where is sine positive? Quadrants 1 and 2, reference angle 30. So the measure of angle theta in quadrant 1 is 30 degrees, and in quadrant 2, 150, because we're doing 180 minus 30. And you could check that on your calculator as well. So we'll clear this one out, and it is for cosine x squared plus for sine x minus 5, and y2 equals 0 is fine. Let me check my window. My window is good. Let me make sure my mode is good. Yep. So you can see that it's intersecting in two spots, and since I'm going by 30s, you can see that those spots are 30 and 150, but if not, you can do second trace intersect, and we'll get the 151. And there it is, 149.99999, but that's really 150. So we are correct. Next one, next page. So we have 3 tan equals cotan. Now, it really wouldn't make sense to write sine over cosine and cosine over sine, because, again, we'd have two variables. We'd have an x and a y in our problem. So I'm going to replace cotan with 1 over tan. So 3 tan theta equals 1 over tan theta. And then I have a proportion that I can solve. So it's really now like 3x over 1 equals 1 over x. So when you cross multiply that, you get 3x squared equals 1. And then I'm going to divide both sides by 3 and get x squared equals 1/3. And then I'm going to square root both sides. And when I do that, I have to do plus or minus. So I really have x is equal to plus or minus 1 over radical 3. But rationalizing that, it's really plus or minus radical 3 over 3. So I'm really solving tan theta equals plus or minus radical 3 over 3. So I'm doing tan theta equals positive, and I'm doing tan theta equals negative radical 3 over 3. And so when I set that up, quadrant 1 and 3 for tan is positive, reference angle 30, sine just saying that it's positive. So theta, the measure of angle theta for this problem, is 30 and then 180 plus 30, which is 210. And then for the negative one, I would be looking in quadrants 2 and 4. Reference angle is still 30. So the measure of angle theta for this is 180 minus 30, or 150, and 360 minus 30, or 330. And again, if you wanted to check that, they should intersect at those points. Let's take a look at that real quick, though. We're going to have some undefineds here. So if you are going to check this one, I would enter in 3 tan, and then in y2, I would enter in not 1 divided by tan, but cos divided by sine. Talked about this back in the graphing chapter. And then this way you do not get the undefineds. Oops. There we go. So I have four answers. I'm looking for where they intersect, not where they intersect the x-axis now. And you can kind of see the 30, the 150, the 210, but we'll do one of them. So second trace, intersect. There we go. Nope. Okay. There we go. Sometimes you have to move it around so you can actually see the cursor. So there was the 210, and if we did the other intersections, we'd get the same answers we have. All right, next one. 2 sine theta. Let me erase this first. Okay. We have 2 sine theta plus 1 equals cosecant theta. So to solve that, we would, again, want to replace cosecant theta with 1 over sine. And so then we'd have 2 sine theta plus 1 equals 1 over sine. And so now I'm going to look at that as 2x plus 1 equals 1 over x. And I'm going to cross multiply. So it would be x times 2x plus 1 equals 1 times 1. So it's 2x squared plus x equals 1, which is 2x squared plus x minus 1 equals 0. And this actually factors to 2x and x, 1 and 1, plus, minus and plus, the other way around. So then we would have 2x minus 1 equals 0, and x plus 1 equals 0. So we'd have x is negative 1, 2x is 1, x is 1/2. So it would be sine, not cosecant. So sine theta is equal to 1/2, and sine theta is equal to negative 1. So if you go to your calculator and you type in second sine of negative 1, it gives you negative 90. The answers are supposed to be from 0 to 360. So this is one of those quadrantals. So you should be checking all the way around that unit circle. The sine of 0, the sine of 90, the sine of 180, the sine of 270. Or on that unit circle, you should be looking for where the y-coordinate is negative 1. And it's right there at 270. Okay? If you're at 0, you're looking at a y-coordinate of 0. If you're at 180, that's negative 1, 0, also 0. And if you're at 90, you're going to be at positive 1, because this point is 0, 1. So I'm looking at all the y-coordinates. So the measure of angle theta here is 270. So that's my answer for that part. And the other one, we did a previous one. I'm pretty sure the measure of angle theta is 30 and 150. Okay. Next one, tan and cotan. I'm pretty sure yours actually says cosine. It says something different than this. I'm pretty sure. For cosine squared. Nope. Hold on. 2 cosine squared So yours says 2 cosine squared minus tan theta cotan theta instead of 2 sine squared. Okay, well, if you go and you look at, just leave the cosine squared alone for a second, and convert the cotan to 1 over tan. You do that, the tan thetas will cancel. So you're really just looking at 2 cosine squared theta minus 1 equals 0. So you're really just solving 2x squared minus 1 equals 0, which doesn't factor, so you add 1 to both sides, divide by 2, and take the square root. And then that's plus and minus. So we get x is equal to plus or minus 1 over radical 2, which when we rationalize is radical 2 over 2, plus and minus. So we really end up with cosine theta is equal to plus or minus radical 2 over 2, which gives you cosine theta is equal to positive radical 2 over 2, and cosine theta is equal to negative radical 2 over 2. So now, when we QRS, it's in 1 and 4. Reference angle is 45. So our answers for theta are 45 and 360 minus 45, which are 315. So there's 2 answers. And then the next one, we would be a negative, so it's quadrants 2 and 3. Still a reference angle of 45, both negative. And so now the measure of angle theta is 180 minus 45, or 135, and 180 plus 45, which is 225. And again, if you put those on the calculator, they would check. Okay, so let's take a look at one more. We've got a few more minutes. You can just add this somewhere. So 2 cotan squared theta plus 3 equals 3 cosecant theta. Okay, now on this one, it's a little trickier. I would use an identity. I would say that I know 1 plus cotan squared equals cosecant squared. So on the side over here, I know 1 plus cotan squared equals cosecant squared. So if I want to solve for cotan squared, I would subtract 1 from both sides. So I'd get cotan squared theta equals cosecant squared theta minus 1. So I'm going to replace that and do 2 times cosecant squared theta minus 1. So it's not going to do me any good to replace cotan squared with cosine over sine and then cosecant with 1 over sine, because that would give us an x and a y. We don't want different variables. We want the same variables. So now, with this one, if we distribute, we get 2 cosecant squared theta minus 2 plus 3, and I'm going to subtract the 3 cosecant theta, so we set that equal to 0. So this would really be cleaning it all up, 2 cosecant squared theta minus 3 cosecant theta plus 3 equals 0. Or really, we have 2x squared minus 3x plus 3 equals 0. So that's 2x and x. And let's see. If I go with 3 and 1 there, that's not going to work. They'd have to both be negative. So it looks like we might have to use the quadratic formula. All right, so x equals negative b plus or minus square root b squared minus 4ac all over 2a. So we get 3 plus or minus 9. You know what? This one is not going to work out in its current state. I probably should have made this -3, -3. So then I do positive. Let's see if that works. Like that. So it would be, no, that would still be a problem. All right, let's just scrap this problem because it's going to give me a negative under a radical. I must have copied the wrong one down. Sorry. Good for you. You can be done. And maybe ask your teacher to do one with a cotan and a cosecant in class with you tomorrow instead. Okay? Thank you. Have a good night.